Hello everyone, I am Meenu from VIT University. Today we are going to learn about the topic OSI model. Now the question arises, what is OSI model? OSI model is Open Systems Interconnection Model. It is a model for understanding and designing a network architecture. It is a layered framework for the design of network systems for communication. It is composed of 7 separate but related layers. Now, looking at the different layers of the OSI model, first layer is physical layer, second is data link layer, third is network layer, fourth is transport layer, then is session layer, then is presentation layer, and finally application layer. Now, looking at the organization of these layers, layer 1, 2 and 3, that is physical layer, data link layer and network layer are network support layers. They deal with the physical aspects of moving data. Layers 5, 6 and 7, that is session layer, presentation layer and application layer, can be thought of as the user support layers. They allow interoperability among unrelated software systems. Fourth layer, that is transport layer, links the two subgroups. Now we will look at the individual layers and their functions in the OSI model. This is a diagram of the 7 layers of OSI model. First layer is physical layer. Now we will look at the functions of the physical layer. It coordinates the functions required to carry a bit stream over a physical medium. It defines the physical characteristics of interfaces and medium involved in the communication. Representation of bits. Data has to be converted to signals for transmission, that is, encoding and decoding is done by physical layer. Data rate. The rate at which bits are sent per second is known as data rate. The data rate is also decided by physical layer. Synchronization of bits. The rate, it is necessary that the rate at which sender is sending the data should be equal to the rate at which the receiver is receiving the data. Line configuration. The physical layer is concerned with the connection of devices to the medium. In a point-to-point configuration, two devices are connected through a dedicated link, while as in a multi-point configuration, a link is shared among several devices. Next is physical topology. The physical topology defines how devices are connected to make a network. Devices can be connected by using a mesh topology, a star topology, a ring topology, a bus topology, or a hybrid topology, that is a combination of two or more topologies. Next is transmission mode. The physical layer also defines the direction of transmission between two devices, that is simplex, half duplex or full duplex. In simplex mode, only one device can send, the other can only receive. The simplex mode is a one-way communication. In half duplex mode, two devices can send and receive, but not at the same time, while as in full duplex mode, two devices can send and receive at the same time. So, this was all about physical layer and its functions. Second layer in OSI model is data link layer. The data link layer transforms the physical layer, a raw transmission facility, to a reliable link. It makes the physical layer appear error-free to the upper layer in the OSI model. Framing. The data link layer divides the stream of bits received from the network layer into manageable data units called frames. Physical addressing. If frames are to be distributed to different systems on the network, the data link layer adds header to the frame to define the sender and or receiver of the frame. If the frame is intended for a system outside the sender's network, the receiver address is the address of the device that connects the network to the next one. Next is flow control. If the rate at which the data are absorbed by the receiver is less than the rate at which data are produced in the sender, the data link layer imposes a flow control mechanism to avoid overwhelming the receiver. Next function of data link layer is error control. The data link layer adds reliability to the physical layer by adding mechanisms to detect and retransmit damaged or lost frames. It also uses a mechanism to recognize duplicate frames. Error control is normally achieved through a trailer added at the end of the frame. Next important functionality of data link layer is access control. When two or more devices are connected to the same link, data link layer protocols are necessary to determine which device has control over the link at any given time. Next layer in the OSI model is network layer. The network layer is responsible for the source to destination delivery of a packet, possibly across multiple networks, whereas the data link layer oversees the delivery of the packet between two systems on the same network. The network layer ensures that each packet gets from its point of origin to its final destination. If two systems are connected to the same link, there is usually no need for a network layer. However, if the two systems are attached to two different networks with connecting devices, the The transport layer is responsible for process-to-process delivery of the entire message. A process is an application program running on a host, whereas the network layer oversees source-to-destination delivery of individual packets. It does not recognize any relationship between those packets. It treats each one independently, as though each piece belonged to a separate message, whether or not it is. The transport layer, on the other hand, ensures that the whole message arrives intact and in order, overseeing both error control and flow control at the source to destination level. Source to point addressing. Computers often run several programs at the same time. For this reason, source to destination delivery means delivery not only from one computer to the next, but also from a specific process running on one computer to a specific process running on other computer. The transport layer header must therefore include a type of address called service point address or port address. The network layer gets each packet to the correct computer. The transport layer gets entire message to the correct process on the computer. Segmentation and reassembly. A message is divided into transmittable segments with each segment containing a sequence number. These numbers enable the transport layer to reassemble the message correctly upon arriving at the destination and to identify and replace packets that were lost in transmission. Connection control. The transport layer can be either connectionless or connection oriented. A connectionless transport layer treats each segment as an independent packet and delivers it to the transport layer at the destination machine. A connection-oriented transport layer makes a connection with the transport layer at the destination machine before delivering the packets. After all the data are transferred, the connection is terminated. Like flow control. Like the data link layer, the transport layer is responsible for flow control. However, flow control at this layer is performed end to end rather than across a single link. Next is error control. Like the data link layer, the transport layer is responsible for error control. However, error control at this layer is performed process to process rather than across a single link. The sending transport layer makes sure that the entire message arrives at the receiving transport layer without error, that means without any damage, loss or duplication. Error correction is usually achieved through read. The next layer in the OSI model is presentation layer. Now, looking at the functionalities of the presentation layer. The presentation layer is concerned with the syntax and semantics of the information exchanged between two systems. Translation. The processes running in two systems are usually exchanging information in the form of character strings, numbers and so on. The information must be changed to bit streams before being transmitted. Because different computers use different encoding systems, the presentation layer is responsible for interoperability between these different encoding methods. The presentation layer at the sender changes the information from its sender dependent form into a common format. The presentation layer at the receiving machine changes the common format into its receiver dependent format. Encryption. To carry sensitive information, a system must be able to ensure privacy. Encryption means that the sender transforms the original information to another form and sends the resulting message out over the network. Decryption reverses the original process to transform the message back to its original form. Next function of presentation layer is compression. Data compression reduces the number of bits contained in the information. Data compression becomes particularly important in the transmission of multimedia such as text, audio or video. So this was all about presentation layer. Now the last and final layer in the OSI model is application layer. Now we will look at the functionalities of the application layer. The application layer enables the user, whether human or software, to access the network. It provides user interfaces and support for services such as electronic mail, remote file access and transfer, shared database management and other types of distributed information services. Of the many application services available, the following specific services are provided the application layer.